Okay, problem 12 on the review worksheet. They were nice enough to tell you that you're supposed to evaluate this limit using L'Hopital's rule. Honestly, though, they don't really need to tell you that. The first thing you would try with any limit problem is direct substitution or plug and chug. And if we put an infinity in for x right here, let's see what would happen. Infinity to the fifth power becomes something huge, right? It's infinity, and the natural log of infinity, if we remember what our graph of y equals the natural log of x looks like, something like this. As x goes off towards infinity, y is approaching infinity as well. So the numerator here is going to be infinity. And in the denominator, infinity plus 1, that approaches infinity. To the fifth power, infinity. Natural log of that, infinity as well. So this is one of the cases where direct substitution gets you infinity over infinity, and that means that it's okay to evaluate this limit using L'Hopital's rule. So the limit we're trying to come up with then would be equal to the limit as x approaches infinity of, and here we go now, guys, we're going to take the derivative of both the top and the bottom. So the derivative of natural log of anything is 1 over that product, so 1 over x to the fifth, but multiplied by the derivative of that product. And the derivative of x to the fifth is going to be a 5x to the fourth. Now down on the bottom, I can clean up that top in just a second, but I'll get to that in a moment. Down on the bottom, kind of the same thing. We've got the derivative here of natural log of something, so it's going to be 1 over x plus 1 to the fifth times the derivative of that product, 5 times x plus 1 to the fourth power. Now I think both the numerator and the denominator there can be cleaned up a little bit, so let's see what we can do. X to the fifth and x to the fourth, okay, all of those are going to go away. You're going to be left with 1x right there, so that numerator now looks like it's going to be 5 over x. And in the denominator, x plus 1 to the fourth cancels with 4 of those, and that's going to be a 5 over an x plus 1. Okay, and now that whole complex fraction, I think, can be simplified further. Limit as x approaches infinity of, all right, remember how this works, guys. The x plus 1, this is the denominator of the denominator, goes all the way up here to the top. So this numerator becomes a 5 times the quantity x plus 1, and the denominator now is these two things put together, which is going to be a 5x. Okay, one last thing happens here. The 5's cancel, and we just now get the limit as x approaches infinity of x plus 1 over x. And after all that work, if we let x actually approach infinity, my numerator approaches infinity, and so does my denominator. So I've got infinity over infinity yet again, which means that I think we're going to need L'Hopital's rule a second time. But I think this one is going to be much easier than it was the first time. The derivative of x plus 1 is just 1. And in the denominator, the derivative of x is just 1. And the limit as x approaches anything of 1 over 1 is 1. So that looks like our answer to this problem right here, guys, which basically tells us that the numerator and the denominator are increasing at essentially the same rate. So we had to do L'Hopital's rule once, then do a whole bunch of simplification, and then we were able to do L'Hopital's rule a second time, and we ended up here with our answer of +1.